Terraforming is like giving a planet a makeover, transforming it to be more like Earth. Imagine taking a dry, dusty planet and making it warm and wet, with breathable air and oceans. That's terraforming. It's a big idea, and it would take a very long time, but it could allow humans to live on other planets someday. Think of it like gardening, but on a massive scale. We wouldn't just be planting trees, we'd be changing the entire atmosphere, creating rivers and lakes, and making the temperature just right for life to thrive. This is a huge engineering challenge, but the potential rewards are even greater. Terraforming is still a theoretical concept, but scientists and engineers are already exploring the possibilities. It captures our imagination and pushes the boundaries of what's possible, offering a glimpse into a future where humanity might live among the stars. Mars is often called Earth's twin for a reason. Despite being millions of miles apart, these two planets share some striking similarities that make Mars a fascinating subject of study and exploration. It's the most similar planet to ours in our solar system. Its landscapes, with vast plains, towering volcanoes, and deep canyons, mirror some of the geological features we find on Earth. While Venus is closer in size, it's incredibly hot and has a toxic atmosphere. The surface temperature on Venus is hot enough to melt lead, and its thick clouds of sulfuric acid make it an inhospitable place for life as we know it. Mars, on the other hand, has some promising features that make it a good candidate for terraforming. Its surface conditions, while harsh, are not as extreme as those on Venus. For starters, Mars has ice at its poles and in its soil. This ice is not just a scientific curiosity, it represents a potential resource for future explorers and settlers. This ice could be a source of water, a crucial ingredient for life as we know it. Water is essential not only for drinking but also for growing food and producing oxygen. It also has a day-night cycle similar to Earth's, rotating on its axis every 24.6 hours. This similarity could make it easier for humans to adapt to life on Mars. This means plants and animals from Earth could potentially adapt to the Martian day. The possibility of growing Earth crops on Martian soil is an exciting prospect for sustaining human life on the red planet. While Mars is a harsh environment now, it's the most promising candidate for terraforming in our solar system. Its thin atmosphere and cold temperatures present challenges, but they are not insurmountable. Its similarities to Earth, along with the potential for water and a suitable day-night cycle, make it the most logical choice for expanding humanity's reach beyond our home planet. The dream of turning Mars into a second home for humanity is not just science fiction, it's a goal that scientists and explorers are actively working towards. Terraforming Mars wouldn't happen overnight. It would be a gradual process, taking centuries and involving multiple stages. Each stage would build upon the last, slowly transforming the red planet into a more habitable environment. The first stage would likely involve warming the planet. Because Mars is further from the Sun than Earth, it's much colder, with an average temperature of about -80 degrees Fahrenheit. We would need to find ways to trap more of the Sun's heat on Mars to raise the temperature and melt the polar ice caps. As the planet warms, the ice would melt, releasing carbon dioxide and water vapor into the atmosphere. This would thicken the atmosphere and create a greenhouse effect, further warming the planet. Once the temperature and atmosphere are more Earth-like, we could begin the next stage introducing life. Terraforming Mars is a monumental engineering challenge. The idea of transforming an entire planet to make it habitable for humans is both fascinating and daunting. It requires a deep understanding of planetary science, advanced technology, and innovative engineering solutions. The scale of the project is unlike anything we've ever attempted. On Earth, we've undertaken massive engineering feats, but Mars presents an entirely new level of complexity. The distance from Earth alone adds layers of logistical challenges. We're talking about changing the climate of an entire planet. This involves altering weather patterns, temperature, and even the composition of the atmosphere. It's a task that requires precise calculations and long-term planning. This presents a unique set of hurdles that we'll need to overcome. Engineers and scientists must work together to develop new technologies and methods to address these challenges. The collaboration between different fields is crucial. One of the biggest challenges is the thin Martian atmosphere. The atmosphere is not only thin but also lacks the necessary components to support human life as we know it. It's about 100 times thinner than Earth's and composed mostly of carbon dioxide. This means that the air pressure is extremely low, making it impossible for humans to breathe without assistance. This means there's very little air pressure, and humans wouldn't be able to breathe on Mars without specialized suits. These suits would need to provide not only oxygen but also protection from the harsh environment. We'd need to find a way to thicken the atmosphere and add oxygen. This could involve releasing greenhouse gases to warm the planet or using advanced technology to generate oxygen. Another challenge is the lack of a global magnetic field like Earth's. This magnetic field is essential for protecting the planet from harmful solar radiation. This magnetic field protects us from harmful radiation from the sun. Without it, Mars is exposed to high levels of radiation, which can be detrimental to both human health and electronic equipment. Without it, life on Mars would be exposed to dangerous levels of radiation, making it difficult for life to survive. This radiation can damage DNA and increase the risk of cancer. Finding a way to shield Mars from radiation is crucial for long-term habitability. This could involve building habitats with thick walls or developing new materials that can block or absorb radiation effectively. Section 5. Powering a planet, energy demands of terraforming. Transforming a planet requires an immense amount of energy. We'd need to power giant machines, melt ice caps, and create artificial magnetic fields. Where would we get all this energy? Solar power is one option, but Mars receives less sunlight than Earth. We'd need to build vast solar farms covering large swaths of the Martian surface. Nuclear fusion, which powers the sun, is another possibility, but it's a technology we haven't fully mastered yet. Efficient energy storage is also critical. Mars, like Earth, has day and night cycles. We'd need to store energy generated during the day to power operations during the night. Developing advanced batteries or other energy storage solutions is vital for a sustainable Martian colony. Section 6. Breathing life into Mars. Creating a breathable atmosphere. Perhaps the biggest challenge of terraforming Mars is creating an atmosphere humans can breathe. The current Martian atmosphere is thin and toxic to us. We'd need to both thicken the atmosphere and change its composition. One idea is to release trapped greenhouse gases. These gases are found in the Martian soil and polar ice caps. Releasing them would thicken the atmosphere and trap more heat, warming the planet. However, even with a thicker atmosphere, we'd still need to add oxygen. This could be done by introducing plants which produce oxygen through photosynthesis. It's a long and complex process, but creating a breathable atmosphere is essential for humans to live on Mars without relying on spacesuits. Section 7. From ice to oceans. Water on the red planet. Water is essential for life as we know it. Luckily, Mars has water ice trapped in its polar ice caps and beneath its surface. Melting this ice would be crucial for creating oceans and a water cycle on Mars. This could be achieved by intentionally warming the planet, causing the ice to melt naturally. We could also use targeted energy sources to melt the ice more quickly. Once there's liquid water, we could potentially introduce microbial life to begin transforming the Martian soil. The presence of liquid water would also open up the possibility of growing plants on Mars. Plants could contribute to oxygen production and help create a more Earth-like environment. Section 8. The long view, sustainability, and the Martian future. Terraforming Mars is not just about making it habitable, it's about ensuring it remains habitable for future generations. This means creating a sustainable ecosystem that can support life without constant intervention. We need to consider the long-term consequences of our actions. How will introducing Earth life affect the Martian environment? Can we create a closed-loop system that recycles resources efficiently? These are complex questions with no easy answers. The ethical implications of terraforming are also important to consider. Do we have the right to alter another planet so drastically? What if there's microbial life already on Mars? These are questions that require careful consideration before we embark on such an ambitious project. Section 9. Conclusion. A planet for our children's children. Terraforming Mars is an incredibly ambitious undertaking, a project that would span generations and push the boundaries of human ingenuity. It involves transforming the harsh, barren landscape of Mars into a habitable environment, a task that requires not just advanced technology, but also a deep understanding of planetary science and ecology. The vision of turning Mars into a second Earth is not just a scientific challenge, but also a philosophical one. questioning our place in the universe and our responsibility towards future generations. It's a testament to our desire to explore, to push the limits of what's possible, and to secure a future for humanity beyond Earth. The journey to Mars is filled with unknowns, but it's this very uncertainty that drives innovation and discovery. Each step we take on this red planet brings us closer to understanding not just Mars, but also our own planet and the broader cosmos. While the challenges are immense, so are the potential rewards. The process of terraforming Mars could lead to breakthroughs in renewable energy, sustainable living, and even medical advancements. The technologies developed for Mars could be applied to solve some of Earth's most pressing problems, creating a symbiotic relationship between our two homes. Imagine a future where humans live on two planets, where Mars is no longer a distant red dot in the sky, but a second home for our species. This vision of a multi-planetary existence is not just science fiction, it's a real possibility that scientists and engineers are working towards every day. The idea of living on Mars opens up new horizons for human civilization, offering a fresh start and new opportunities for growth and development. While we may not see a fully terraformed Mars in our lifetime, the journey of getting there will undoubtedly lead to incredible discoveries and technological advancements that benefit all of humanity. The research and development required for Mars colonization will push the boundaries of what we know and can achieve, fostering a spirit of collaboration and innovation that transcends borders and unites us in a common goal. The idea of terraforming captures our imaginations and inspires us to think big. It challenges us to dream beyond our current limitations and to envision a future where humanity thrives on multiple planets. This grand vision serves as a powerful motivator, driving scientific inquiry and technological progress. It's a reminder that as a species, we're capable of achieving extraordinary things when we set our minds to it. The collaborative efforts of scientists, engineers, and visionaries from around the world demonstrate the power of human ingenuity and determination. Together, we can overcome the challenges and make the dream of a multi-planetary future a reality. Terraforming Mars is a long-term goal, a vision for the future that will continue to inspire generations to come. It's a journey that will shape the destiny of humanity, offering new possibilities and a sense of hope for our children's children. As we look to the stars, we are reminded of our potential to create a better future, not just for ourselves but for all who come after us.